Hello everyone. Today we are going to talk about one of the most amazing and interesting topic of all physics, that is special theory of relativity, and that is going to be an amazing discussion on physics. And in today's this amazing discussion, physics discussion, we have our special guest, my best friend Ayush Adhikari. I want to welcome to my friend Ayush Adhikari to this discussion. Welcome to our this amazing discussion, Ayush.
Thank you, Subash, for welcoming me in this discussion. And it's my pleasure and honor also to talk to you about those physics stuffs and in this video. Okay, Subash. Now, at first, give a short glimpse about those topics that we will be talking about in this video, so that our audience will be more effectively able to
Mhm.
connect to our video. Now, first, give those topics.
Okay, I will connect what we will be talking about today's video. Okay, today we'll talk about a special theory of relativity, and that's a very amazing topic, quite interesting topic of physics. Yeah, we already know that, and all the audience and all the people wants to talk about that special theory of relativity and wants to hear about that special theory of relativity. And at the first time that when someone talk about special theory of relativity, and the listener will think about that's like science fiction, that's like abnormal. How is that possible like
Yeah.
that? And someone talk about like time travel to that person, and how is that possible? He's lying to me, or like he's making me fool like that. But then that's
Hello.
possible, and we'll all explain about that with the explanation also. Yeah, we'll make feel to the audience also. Yeah, and today we'll talk about that time travel, how time travel is possible, and how time gets dilated. We'll connect about that also idea with some explanation also. And what do you mean by going at future, and what do you mean by going at future, that past? Why is that going at past is very difficult than going at future? We'll talk about that also, and we'll shortly talk about that E equals to mc square formula, that energy and mass are equivalent thing. They are the
Mm,
same thing but different manifestation of the same thing. We'll talk about that also. And yeah, audience will like that video obviously, and I want to recommend all those audience that uh, watch the video till the end, and you will feel what's the special theory of relativity, and you will feel about the time travel and going at future. What does that actually mean, and what actually means time dilation or length contraction? You will get the idea about that. Okay, let's start. Okay.
Subhash gave a nice introduction about those topics. I also recommend the audience to watch the video to till the end so that they will be more clarified about these topics. Now let's directly move. No, before directly moving to the topic, let's move. Let's go through some background. In about 1905, Einstein was about like 26 to 25, 26 years old. He published four papers. First two papers were about like Brownian motion and photoelectric effect, for which he was awarded Nobel Prize. And last two papers were about like special theory of relativity. And we will be talking about special theory of relativity in this video. So in special theory of relativity, there are mainly two postulates: Einstein's first postulate and second postulate.
Yeah.
Now I'm
Mm.
now let's move to that first postulate, Einstein's first postulate. Einstein's first postulate is
Okay.
also called like a principle of relativity. It says in this way, like all the physics laws of physics are same in every initial frame of references. I want to make clarify about this word initial frame of references to our audience so that they will be able to connect more. Like inertia frame of references it can be any system which are in stationary or in uniform motion can be taken as initial frame of reference. You can just surfacely imagine from this word's meaning initial frame of reference. Frame of reference. Reference anything that
Mhm.
can be taken as a reference, isn't it? This is
Mhm.
like initial frame of
Yes.
reference. So anything, any system that is in rest or uniform motion can be taken as initial frame of reference. So this is like a definition. Or
Yes.
This is the meaning of this word. Now, let me clarify this for Einstein's first postulate. 12 example. The example of EMF, induced EMF.
Mhm.
As you all know, from the Faraday's law of electromagnetic induction, from that law, as you all know that unchanging magnetic flux linked with the coil, and EMF is induced, and EMF is induced in the coil. Now, let's take a simple example. In which there is a coil and a permanent magnet is moving towards the coil.
Mhm.
Due to as it is moving or moving towards the coil, EMF is induced. Let's see this simple experiment from two different perspectives, from two different references. Let's see from that magnet side. Let's suppose I am at the magnet,
Yeah,
at the top of magnet.
you are observing the same. Yeah, you are observing the same experiment or
Yes,
same event in the different perspective.
yes,
And what
from
will
two
happen?
different
There will be
perspectives.
different value or
Yes,
same value.
yes,
Yeah.
exactly. Let's see from that magnet perspective. Suppose you are at the top of the magnet, and in that
Yeah.
experiment, you will feel like that coil is moving towards you. If you are on the top of the
Yeah.
magnet, then you are also in the motion of the magnet, isn't it? So you will feel like that coil is moving towards you.
Yeah.
And in this case also, EMF is induced because there is the magnetic flux linked in the coil changing continuously, so EMF is induced, isn't it? Yes. And let's see this same experiment from different perspective, from that perspective of the coil. The coil, let's suppose you are at the top of the coil, then you will see that magnet is moving towards you. And in this case of the EMF is induced due to changing the magnetic flux. In both cases, in from both perspective, you can say like EMF is induced in both perspective. EMF is induced of same magnitude also, because this is the same
Yes.
experiment. In this so in from both that from both perspective, from both references, EMF is induced, means physics laws of physics is same from both perspective. So you can say like whether you are in any initial frame of reference, all the physics laws that are valid can be applied. This is the simple
Mhm.
but very powerful like postulate of Einstein. This is all about. Okay, I have explained about the first postulate of special theory of relativity. Now Subash will continue with the second postulate of special theory of relativity.
Okay.
Okay, Subash.
Okay. Uh,
Okay, continue.
okay. Second postulate is the heart of special theory of relativity. It's the core of that special theory of relativity. How Einstein came with this postulate or with this idea. Firstly, how he thought it can be a constant tendency of the speed of light. How he thought about that too. Let's talk about that first.
Okay,
And
sure.
he thought himself he himself pushes at the speed of light, and he tries to see that electromagnetic wave, and he couldn't see if
Electromagnetic
he
radiation.
see with the classical view, because that electromagnetic wave or that light is moving with the same speed as 20
Subash,
million kilometer per
Subash,
second. Yeah.
can you put your mic near your mouth so that your sound will be much clear?
Okay. No problem.
Yeah,
And
yeah,
yeah.
continue. Yeah,
Uh,
yeah, it's not clear.
okay. Okay. It's now clear.
Yeah, yeah.
Mm. Okay, let's talk about how Einstein came with this idea that is constancy of speed of light. Okay, and he himself put with the speed of light and tries to see that electromagnetic wave or that light, but he couldn't see if he see with the classical view, because if something are moving with the same speed, then they couldn't see that whether another thing is moving or not. Yeah,
Mm,
in the same way, you will not be able to see that electromagnetic wave passing from him or not, and
yes,
all
exactly.
that electromagnetic wave will stop at that point, and all those things will be stopped at that point, and so that at that point, all those Maxwell equation, all that electromagnetic law, electromagnetism will break at that point. And that what that can be, that violates the laws of electromagnetism. And so, with this idea, Einstein concluded that the speed of light, that c, that should be constant for all observers, whether you are in motion or whether you are at rest. Light should passes from you with the perspective of you with the same speed as zero point 0.3 million kilometer per second. That is the idea from which Einstein came with this postulate, and that is actually the heart of that special theory of relativity. From this
Yes.
idea, we can explain about time dilation, how can time dilate, and we will explain about that later. And yeah, that is the main postulate of the special theory of relativity, obviously. And yeah, and if we let me explain one thing, okay? And we know
Yeah.
already that speed is space divided by time, or that length divided by time, or distance divided by time, whatever we call.
Yes.
And so that to be that c constant, that speed should to be constant, that space and time, or that length or time should have real feature. And so that speed of light should will be constant in any situation. Yeah, that was so that space and time has weird feature. Sometimes space changes or length contract. We will talk about length contraction, and space gets contracted, or time gets dilated. Time gets dilated means
Yeah.
time ticks at a slower rate. And yeah, this kind of weird feature will come in that in space and time. And that was all about special, that second postulate of the special theory of relativity. And we can talk about something, one explanation also. And if I'm moving with the half of the speed of light in a train, and uh, someone exposes laser light from me, and it will passes again with the same speed that c from me also, with respect to me also, and with respect to a person who is at rest also.
Mhm.
The light will travel with the same speed. And also, we have another explanation. Yeah, could you explain that also, that nice explanation about that spacecraft firing that some
Yeah.
bullet
Yeah.
also with the same
Yeah.
speed of light? Yeah, that's also a nice explanation. Yeah.
Should I share this explanation, or you will?
Yeah, you can explain about that. Yeah.
Okay, okay, sure. Okay, let me share you about an quite interesting example. Let's suppose there is an spacecraft
Mm-hmm.
which is on whose nose or on whose head there is a nozzle which can fire a beam of laser, or
Mm-hmm.
it has that spacecraft has a laser gun. You can say that, you can just say that.
Mm-hmm.
And so let's
Yeah.
suppose that spacecraft is moving with quite more speed, nearly about c. It is moving in space
Mm-hmm.
nearly about c speed of light, and during its motion it fires the laser. It fires the laser as it is as it itself is moving with c, and it's fire a laser which is also moving with c, isn't it? Then at that point, if we think surfacely, then we would think that laser and spacecraft is moving parallelly, isn't it? Because its speed is also c, its speed is also c. Then if their velocity or if their speed are same, then if we think generally, then their velocity will be same, and they will be moving parallelly, isn't
Yes.
it? If we think surfacely,
Yes.
then but in this case this is sorry, it does not happen, because there is laser means obviously light, isn't it?
Yeah.
Laser means light. Then light, if that system, so that spacecraft is moving, then it fires a laser, then laser will also move with the speed of light c with respect to that spacecraft also.
Yes.
Because speed of light is constant with any so with every initial frame of reference. That spacecraft is one
Yes.
initial frame of reference. So if that beam is fired, if that laser is fired, then its speed will be c with respect to that spacecraft also, because spacecraft is an initial frame of reference. If you are in that spacecraft, then you will see that the laser is moving ahead you with c.
Mhm.
And if you are on the earth and moving both spacecraft, and you are observing that both spacecraft as well as that beam, then you would see that
Mhm.
laser is also traveling with c, that beam is also
Mhm.
traveling with that spacecraft is also traveling with c.
Mhm.
If you think surfacely, then you would think like spacecraft is moving with c. It fires a laser which is
Mhm.
capable of traveling with c with respect to that spacecraft also. Then if we
Mhm.
use our general mind, then we would say that speed of that laser is 2c, because the spacecraft is moving with c. It fires a
Yeah.
laser, then its laser's speed would be 2c if you think general
Mhm.
surfacely. Then but this is
Mhm.
not this doesn't happen,
Mhm.
as speed of light is
Yeah.
constant, and with that initial frame means with respect to earth, as
Mhm.
initial frame of reference, with respect to earth also speed of light is being is c. That's why this
Mhm.
is the second postulate, means speed of light is constant in with respect to every initial frame of reference, isn't it? So
Mhm.
with respect to
Yes.
every, like with respect to that spacecraft also, with respect to our earth also, that speed of
Mhm.
light, speed of that beam is c.
Yeah.
This is
Yeah.
all about this explanation.
Yeah. Whatever we to explain that nice explanation we give with our audience, and
Yes,
the meaning of all those explanation is that constancy of speed of
same.
light in
Yes,
all frame of
absolutely.
reference, in all inertial frame of reference, whether you are at rest or whether you are in motion, or whether you are at nearly speed of light, or whether you are at moving with the speed of light,
Yes,
still that light will passes from you with the
with
speed of
light
light,
is travel with
same
c.
speed of light.
Yes,
Yeah. Yes.
whether you are in that spacecraft or you
That
are
doesn't
in
matter.
like
Yeah.
outer planet, wherever you are with
Yeah.
you will observe that speed of that beam is traveling with c. Light is traveling with c.
Yeah.
Yes, this is
Yeah.
all
That
about
doesn't matter whether. Yeah. That doesn't matter whether you are in motion or whether you are at rest
yes.
or whether you are moving with the speed of light. That doesn't matter.
That
But
doesn't
the
matter.
speed of light is constant
Constant.
or all observable. That is all
Yes.
about second postulate or constancy of the speed of light, and
Yes.
that is the main point of that special theory of
Special
relativity.
theory.
From we have already talked about that constancy of the speed of light, that core of the special theory of relativity. Now let's enter to the about the concept of time dilation. Okay, and time
Okay.
dilation is the very nice that
Yes, it's
concept of
interesting.
special theory of
Yes.
relativity, and it's a very interesting topic, and from which we'll talk about time, what is actually time traveling, what is actually saying to that going to as future, what do you mean that, and we'll talk about that, and we'll connect from a nice explanation to the time dilation, what actually time dilation means, and yeah, we'll talk about that with a nice explanation. Okay, about that the explanation of photon clock experiment. Okay, photon clock
Yeah.
explanation, that is a very nice explanation. Okay, yeah, we are interested to talk about that. Okay,
Yes,
I will
absolutely.
explain about that. Okay,
Okay, thank you. For
let's
that, first I have to share my screen. So let me share my screen. Subash, can you see my screen?
yeah,
Yeah,
definitely.
okay. Now for that, first let me draw.
Okay.
Let me first draw some. Let's suppose this is a train.
Mhm.
Let's suppose this is a train.
Yeah,
Okay.
any
Let's suppose,
system,
yeah, this
train
is
or
a,
any system. Yeah.
yeah, any system, or you can suppose it's a train. This is a
Yeah.
person, and this is
Mhm.
another person. Let's suppose that.
Yeah, let's suppose the person inside the train as a me, Subhash,
Okay.
and the person outside the
Subhas,
train is Ayush.
that's Ayush. Okay. Yeah, we can say that. Yeah.
Okay.
Let's suppose now.
Okay.
Let's suppose here is here is a photon beam of photon, and this is this upper and lower surface is fully silver mirror. Let's suppose this.
Mm-hmm.
Then I'm doing this to make you understand about like clock. Actually,
Mm-hmm.
for before this, I want to share something like what is clock
Mm-hmm.
to us. Will you please
Okay, clock.
explain like this?
Yeah, yeah. Clock actually means about the any system which is any system or any phenomena which is showing the same phenomena, same thing in the fixed period of time, periodic motion. That system is showing periodic motion or cyclic
Yes,
motion. We can say also. If that
exactly.
that type of motion is showing, we can say as a one unit time, as a one period. Yeah, like
Yes,
we can take an example as like simple pendulum, and
yes, yes.
if that simple pendulum is showing one to and fro motion in a particular interval of time, and that
Yes.
one particular interval of time, one to and fro we can call as one unit time. Whatever it can be,
Okay.
one it can be 3.2 second, 5 second, 2 second, 1 second, whatever. But we can call as one unit time that one period, one fixed period as a, and that actually is a time. And in the in the general point of view, we can call it like time is like 1 second, 2 second, whatever like that. That is not actually that clock or like that. That is the time. But
Yes.
clock is actually the system which is showing periodic motion in the particular interval of time. And that particular interval time we can define as one unit time. Yeah, that is
Yes,
actually
exactly.
clock.
Any system that can show periodic motion can be considered as a clock, isn't it?
Yeah,
Yeah. Now,
yeah.
yeah, let's develop one clock here. See,
Okay.
here is a bit. Yeah, let's suppose these two are fully silver mirror. These two upper plate and lower plate are fully silver mirror, and there is a
Hmm.
beam of light. This circular path be a beam of light. So initially, beam of photon. This is suppose this to be a photon. Now it is projected upward. Then
Hmm.
once it strike this upper plate and bounce back to the lower plate again, isn't it?
Yeah.
Now let's suppose the time taken by this photon to hit from this lower plate to upper plate be 1 unit.
1 unit time. Okay.
1 unit
And
time.
yeah, for simplicity, let's name as a upper heating as a tick
Okay,
and
sure.
lower heating as a top. Yeah.
Okay. Now let's if photon strikes this upper plate, then it sounds like tick, and when it like bounce and strike the lower plate, then it will produce a sound like talk. Okay, tick tock, not
Okay.
like tick tock,
Okay.
but tick tock, tick and tock.
Okay.
Okay.
Mm.
Uh, the time in which it strikes the upper plate will be 1 unit. Let's suppose this is a 1 unit. In 1 unit
Mhm,
time, it strikes the upper plate.
mhm,
Then see the initially the this train. Let's suppose this system to be a train. Initially, the train is in
mhm.
rest. So
Yeah.
and this photon is showing periodic motion. No, it is going upward and downward, upward and
Mhm,
downward, upward and downward simultaneously. And this is a clock. In 1 unit
mhm,
time, this is it strikes the upper plate. Is that clear?
mhm,
Yes. Since
mhm.
both
Yeah.
are in rest, this system is in rest, and this Ayush means me and Subash both are in rest, and we are seeing this time clock. Then
Yeah.
the result will be same. Means this photon will go upward and downward, and it is so
Yeah.
periodic motion. We both are seeing
Yeah.
like seeing same.
Yeah.
Yes.
Yeah. It is showing to and fro like motion and
Yes.
bouncing
Exactly.
back and forth like that. Yeah.
Now let's
Yeah.
suppose this train to be in motion now. Second case.
Okay.
In motion
Okay.
with velocity v.
Okay.
Okay. Since the system inside this system, you
Mhm,
Subhas means you and this light clock both are inside that system, and that system is traveling with uniform velocity.
Hmm.
Okay, uniform velocity. Point to be noted. You know.
Yeah, yeah.
Yeah.
Otherwise, it will be non-inertial frame of reference,
Yes,
and we are talking
exactly.
about inertial frame of reference because the that Einstein special theory of relativity is true whenever you are moving with the uniform motion. Yeah.
Yes, exactly. It is in uniform motion. Since the
Hmm.
system, since the system means you and that photon beam both are in uniform motion, then that's why you will not feel any different. Like if you are traveling with a bus, in a bus, if the and bus is
Hmm.
traveling with uniform motion, then you will not feel anything. You will feel like you are in rest, isn't it?
Yeah.
Like in the same way,
There will be no
both
difference. Yeah.
there will be no difference. Like both you will see this clock to be doing the same showing same motion as they were in rest, isn't it?
Yeah. Yeah.
Both you will be saying there, you will be saying you will observe like same, but
Hmm.
I will observe different because I am at rest,
Yeah.
I am on the ground, and you are in a train,
Hmm.
isn't
Hmm.
it?
Yeah.
You are in a
And
train.
yeah, I use.
Azul.
And
Yes.
yeah, I'm inside that train, and that is moving with the uniform speed.
Yes.
Yes, speed
Yes.
means yeah,
Exactly.
in a particular direction it is moving, and
Yes.
it's moving with a uniform speed. And if something is moving with a uniform speed, and that the person, that observer which is inside that train will feel as a casual when
Yes.
you are at
Exactly.
rest. And but you are in outside that train, and it
Yes,
is
I'm
moving.
outside the train, outside the
It is,
system.
yeah, it is, yeah, that train is moving, but
Yes.
for for me that it is bouncing as casual, bouncing back and forth like that when it was at rest. Okay. And but for me it is moving back and forth. And but it is start to move, and after some time it travels some distance. Okay.
Yes,
And after
exactly.
some
Yeah.
yeah, yeah, that
I'm at
upper part
rest.
and lower part, yeah, or upper part and lower part of that mirror will move particular distance. And
Yeah.
so that yeah, and so that that photon should move in a diagonal direction. Yeah.
Yes,
Yeah.
yeah. Let me draw first. Then. You are in a
Okay.
system. This both beam and you both are traveling along the system. Means you are in train and training traveling. But I'm at the
Mm-hmm.
ground. At the ground.
Mm-hmm.
So I'll observe quite different in different way. See, this photon is released from this S1 place, and it will take some 1 unit time to extract the time, extract the upper plate, isn't it? So in this time,
Mm-hmm.
as the train is in motion,
Mm-hmm.
it will extract the upper place at this point, means S2 place,
Mm-hmm.
isn't
Yeah,
it? Yeah.
Ayush, could you make another picture after move some after it has moved some distance after some
Okay,
time,
sure,
like
sure, sure.
yeah, yeah, you can
Sure.
draw below that picture another
Yes, sure.
picture of like that same picture. Yeah, it has moved some distance. Yeah,
Yes.
after some
Yeah.
time because it's.
Initially, that photon was here,
Mhm.
but after some distance, it extracts here.
Yeah,
But after
that
some,
means
that
yeah.
means since that train is in motion here, it will extract here,
Hmm.
and you will be here. After
Yeah,
some time t, after some
yeah,
1 unit time, you'll be here,
yeah,
isn't it? uh,
yeah.
yeah, I think it is clear, so I will draw in this figure so that it will be
Okay,
clear.
yeah.
Okay.
Now
uh,
it's clear. Yeah,
yeah.
I think
Now
audience has also yeah.
I'll erase you now. Now let's see. Initially this photon was released from this point S1, and it extracts at this S2 place, sorry, S2 place,
Yeah.
isn't it?
Yes.
So we can for me, means for Ayush,
Mm-hmm.
outside the system, the path will be
Mm-hmm.
like this. Path traced by that photon will be diagonal, because
Yeah,
it starts
diagonal.
from here, and
Obviously, yeah,
it extracts the
yeah,
upper plate here. So path will be diagonal
yeah,
for me,
yeah.
isn't it?
Obviously, it should be because I
Yes.
have also that me Subash also have traveled some distance that
Yes,
S1 to
exactly.
S2 that distance. Yeah, I have my position has been also changed. You can draw my picture on that also
Yes,
S2 position.
yes, you are here now.
Yeah,
Initially, you
so
were
that
here.
yeah,
Yeah, yeah, you can see this lower picture
yeah,
also. Now see,
mm-hmm,
this photon is seems to travel in diagonal way. For me, I observe this
yeah,
photon is traveling in diagonal way,
yeah,
isn't it?
yeah.
But you are
Yeah,
for you, you
it
are
should travel.
yeah, it should
Yeah,
travel
it
for
should.
but for
Yeah,
you, nothing is different. It is showing to and fro
yeah,
motion like a periodic
yeah,
motion as before, as
yeah,
you in rest,
yeah.
isn't it? For you,
Yes.
nothing is different. But for me, it is
Yeah,
quite different because see, it travels
yeah,
quite diagonal distance, isn't it? Now
yeah,
let's resolve the see. This is the path of photon, isn't it? So speed
mhm,
is, will be always c.
yeah. Always see. Yeah,
Yes, because
obviously.
it is the velocity of photon, always constant, always
Mhm,
c. Now
mhm.
Now let's resolve this into two different components.
Okay.
See, this horizontal component will be obviously equal to that velocity of train, isn't it? Because the
Then yeah,
system is
obviously.
traveling along this side, so you are in
Mhm,
system, so it will be obviously v. Now, if there might be some question in our audience mind, so why
yeah,
for you and me it is different,
yeah,
isn't it? Why for you and me
yeah,
it is different? Now I will explain why. How the
yeah,
time gets dilated. The real field is
yeah,
here. See,
yeah. Yeah, you can explain that also. Yeah, because the audience might be confused
yes,
that
exactly.
for you also that photon should travel with same speed c in the
Yes,
vertical direction
for
also.
for
They might be
everyone,
thinking that. Yeah,
photon speed of
yeah,
photon is same from second
yeah,
postulate
same.
of special theory of relativity.
Yeah,
For everyone, speed of
yeah.
photon will be c. That means
Yeah, but yeah, Ayush, yeah,
yeah,
they might be thinking of that. For me, for Subhash, is that photon is traveling with c in vertical direction.
yes.
Vertical direction. That in upper part of that
Mhm.
uh, mirror. Okay, and audience might be thinking of for Ayush also should that photon traveling in
Yes,
the vertical direction with c, but that can't be.
yes.
Please, can you explain that?
Yeah, I'm talking about this thing. I'm exactly talking
Okay,
about
okay.
this. See, if for me also, if it's travel upward with c, then
Mm-hmm.
in C, the resultant will be more than C, isn't it? Resultant
Yeah,
of these two components will be more than C, means that
yeah,
diagonal path or path of means that resultant means the resultant speed of photon will be greater than C. Then this
yeah,
will not happen, isn't
yeah,
it?
yeah.
So
It will be root square root of c square plus b square obviously from that,
yeah,
right?
it will
And
be there,
yeah,
but there this is not this does not happen, isn't it? That's
yeah.
why. So,
This can be from the second postulate of Einstein's
yes.
theory of relativity. Yeah.
Yes, as the resultant is already C, horizontal
Mm-hmm.
component is B, then vertical component will be less than C, isn't it?
Yeah, less than c.
Less than
That
C.
should be.
That should be less than
Yeah,
C. Means it will
yeah.
take some more time. It will
Mm-hmm.
take some more time to extract the upper plate for me.
Yeah,
For me,
yeah,
but for you, in
yeah,
you can see in figure for you, it's same
yeah.
because you are also traveling in the
It's
same.
casual. Yeah, it's like
It's
casual. Yeah,
yeah, you will feel as casual, but I'll see it's quite different because it for me it
yeah,
will travel some sighted path,
yeah,
and it will its velocity will be quite divided into components, and it will
yeah,
its velocity which is it travel in vertical direction will be slightly
yeah,
less, not slightly, will be less than c, so
yeah.
it will take more time to that extract the upper part, upper plate.
Because yeah, because its vertical velocity of photon has been decreased,
Yes,
and so that
vertical
it will
velocity is
take
decreased, so it will
it
take more time
yeah,
to extract this upper plate.
yeah,
Means, see,
yeah,
it will take some more time to extract this plate.
yeah,
Means for you, 1 second for Subhas, sorry, 1 unit.
yeah, Yeah, 1 unit time.
For Subhas, is same, isn't
Mhm.
it? But for
Yeah, one
me,
unit time. Yeah, same 1 unit time.
but
For
for
you,
me,
yeah,
it is
yeah,
for the
more
time
than
that,
1 unit time. More than one
yes,
unit time. More.
yes,
Yeah,
for me the time that the photon will take to extract the upper plate will be quite more than yours.
yeah, more
That
than
means,
my.
if more than yours means 1 second for, sorry, 1 unit for Subhas will be quite more time. So you might be 2 unit for me also. For me
Oh yeah, yeah.
means 2 unit for me, or I am taking a rough calculation. Sorry, rough sorry, rough values. So
Mm-hmm.
don't mind that, but it will go in this way in the same order. So
Okay.
means time taken by this beam to extract the upper class phosphorus will be same, but for me it will take some quite more time to extract that plate,
Mm-hmm.
extract that
Mm-hmm.
upper plate, isn't it?
Mm-hmm. Yeah.
So in this way, before that, let's suppose that train is traveling with c velocity. Now
Mm-hmm.
let's think that, okay,
Okay.
is traveling with c velocity, then horizontal component of here will be also c,
Mm-hmm.
isn't it?
Yeah.
If the horizontal component is also c and its resultant means the motion of that beam is also c, isn't it? Then
Yeah.
there will be no vertical component.
Mm. Yeah.
You
Vertical
got me or not?
composition becomes zero. Vertical
Yes,
component
vertical
becomes
component
nearly
becomes
zero.
zero means
Yeah.
it will never strike the upper plate.
Yeah. Yeah. For
If it
for the
travel with,
person, for you, for
for me,
Ayush,
yes,
it
for
will
me,
never
point to
strike.
be noted. Yes, for me.
Yeah.
But for you, anything, everything is normal for you. Everything is
Yeah.
as
For
it was in rest. Everything is same.
mm-hmm.
But for me,
Yeah.
it is different.
Yeah.
See,
Yeah.
that's why 1 second for you will be quite more years for me.
Yeah.
Yeah, 1 second for
And
you will be quite more years for me because you are traveling with
mm-hmm.
the sea.
Mm-hmm.
You got me or not?
Yeah, I got you. Yeah, I think audience has also got you about that,
Yes.
and yeah,
I
I
want to
think
get
yeah, it's all
I want to make some one advice to our audience also, because just think about this on your own,
mm-hmm.
because
Mm-hmm.
I have explained in quite easier way also, but you have to like explain, you have to think yourself to get the real feel.
Yeah,
Just
yeah.
think yourself and
It,
draw this figure and just think about this. Yeah, you will
yeah, they have to think about that, and
you
we
have
can
to think
do
about
something.
this
Yeah,
for your,
yeah. We, we
yes,
can we can think about two system. Yeah, use, and it's that we can put one clock, one normal clock on that train moving with some
yes,
uniform velocity, and the clock outside that train, and that means according to this explanation, the
yes,
clock inside that train will ticks in the slow rate, but at, as compared to the clock outside that train, and
yes,
the train outside the train will ticks in the faster rate, but to the as compared to the clock inside that train.
yes,
Yeah.
exactly. Exactly, Suas has said like quite more in quite more easier way. If you
Mm-hmm.
have clock inside the train and outside the train, then
Mm-hmm.
1 second in that train, the clock inside that train will be equal to quite more time for outside the
Mm-hmm.
train. Means if you are
Mm-hmm.
traveling with some more speed, then 1 second
Mm-hmm.
for you will be more than more for outside. Yeah,
Mm-hmm.
there is one formula also, isn't it, Subhas?
Yes. Yeah. Before that formula, let's talk about one thing. Yeah,
Okay,
we used
sure.
to hear that one nice story when we were at high school, or that we used to hear every time that if someone travel in the spacecraft moving nearly speed of light, and
Yeah.
someone lives in the earth, and after some time he return after some time, then there will be there will be vast difference in age between them.
Yes.
And we have heard so many times this story. That's
Yes,
that nice
exactly that.
story. And we used to think, yeah, we used to think it's like science fiction. But like,
Yeah, how,
let's think, yeah, let's
how
think
that's
from this explanation. Yeah, as we move nearly speed of light, then its vertical component nearly becomes zero. That
yes,
means, yeah, for the person living outside that train, or I use or I use
yes,
the clock, that photon never gonna talk on that, never gonna hit upper side of that
outside.
mirror, and it will take so many times. But for the person
Yeah,
that inside the train will
it's
will be
same.
like casual, like
Yes,
it might be like, for one day the person living on that train and the person living outside the train, there will be like one day for the person inside the train will maybe equal to the like 2 year, 3 year, maybe 50 year. If it becomes very near to the speed of light, very 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 near to speed of light, the vertical component becomes nearly very very equal to zero, very very near to zero. And that means never gonna strike. If they never gonna strike means, like, there will be very vast difference in the time, that 1 second might be like 10 year, 100 year, 1,000 year. It might be like
yes.
that also. And yeah, that's a,
Subash,
yeah, logical point
Subash,
of view. Yeah, yeah.
Subash. I think that audience is not
Yes.
also still is not like quite satisfactory about this 1 unit for Subash is going to be 2 unit for me. So in
Hmm.
this in same experiment, I want to say something more. See,
Okay.
initially, yeah, the same system here is
Hmm.
it in rest alongside me, along with me, is in
Hmm.
outside the system. The same system, same the system of beam is outside the train. Okay,
Hmm.
yeah, same beam, same. It is traveling same distance, and it will take some same time, 1 unit time to strike the upper part. It's same. Okay, and if that
Hmm.
system is in motion, then it will take quite more time to extract the upper plate in for if I observe that observe from outside, isn't it?
Hmm.
If I observe from outside, it will take quite more time to strike the upper plate.
Yes.
Means it if the clock alongside me will show in normal way, but
Hmm.
for me that clock inside this train will show abnormal behavior, like 1 second in my clock will still not be equal to 1 second for Suhas clock. You got me or not? Means
Yeah. Yeah.
yeah, it's already
Obviously.
2 second in my clock. I see it's already
Hmm.
2 second in my clock, but still that
Yeah.
beam is not that photon beam is not still able to extract the upper plate.
Yeah.
And let's suppose if it's 3 unit time in my clock, and then only
Hmm.
clock in Subash clock I observe. For me, I observe
Hmm.
the Subash clock to strike the upper plate.
Hmm.
Means if the 1 second for Subas means 1 second for Subas will be equal to 3 unit, or sorry, 3 second for me.
Yeah. Obviously.
If yeah, if I see my if I see the clock on my side,
Hmm.
and if I see the Subas clock, then it will show
Hmm.
different behavior. One
Yeah.
one
There is.
second for if I observe, then 1 second for Subas clock will be equal to 3 second for me, because that
Yeah.
beam will travel quite more distance. Have to travel quite more
Hmm.
distance. That's why
Yes.
it will take quite more time,
Yeah. Quite
isn't
more
it?
time because he
That's
has
why
to travel in the diagonal
1 unit
direction.
in Subas
Hmm.
clock,
Hmm.
CLCK. In 1 unit in Subas clock will be 3 units in my clock. In this way,
Yeah.
this happens.
Yeah.
So I think it's
Yeah. That.
now it's clear, because otherwise,
Yeah. Yeah.
yeah,
Yes. Yes. That depend upon the uh, whether you are nearer to the speed of light or not. If you are
Yes.
not we can calculate also, like if it is moving with near to the speed of light, like point 90% of speed of light, it is moving with that speed, that train, then there will be like a time difference. Like for me, if it is 1 second, then for Ayush it will be like 2.3 second. We can also explain from the formula later. And
Okay.
this is all about like time is like same event is happening in the different time. Yeah,
Yes.
isn't that elegant? Yeah, isn't that elegant? For me, it is like it is taking 1 unit time. Yeah,
Yes.
for the same event, for Ayush, it is taking 3 unit time or 10 unit time or thousand
Yes. Yes.
unit time.
Exactly.
And it,
Yes.
yeah, isn't that elegant? Yeah, that means time is not absolute. It was like in classical view, in Newtonian view, time was fixed. Time in everywhere, wherever you are, or with what velocity you are moving, that doesn't matter. The time was fixed in that classical view. But
Yes.
according to this view,
Yes.
according to this special theory of relativity view, time is relative. Time is different for the event, event the perception of event by two-person in different frame of reference will feel different time. Yeah.
Yeah. Exactly. It means suppose there are two twins.
Mm-hmm.
One goes on that tour of space in fast
Mm-hmm.
moving spacecraft, and another is on the ground surface. After
Mm-hmm.
1 month, that twin with that boy or who is traveling with traveling around the space comes return
Uh-huh.
back, and
Mm-hmm.
they both the brothers meet together. Then there will be quite
Mm-hmm.
a lot of age difference
Yes, it might be
between
50 years,
them
60
because
years,
see,
or yeah, or it might be 2 years also. It might be 10 days
yes.
also. That depends upon the how much nearer to the speed of light you are.
Yes. How much
Yeah.
with what speed that spacecraft is traveling? It depends upon that.
Yes.
Yeah. From this experiment, also you can say this is
Mm-hmm.
for smaller value, smaller C.
Mm-hmm.
If it is nearly around C 0.99999 C or in such speed, then it will be like 1 unit for Subash will be 3 years for, sorry, 1 second for Subash will be 3 years for me or 30 years for me, isn't it?
Yeah. Yeah. Yeah.
In
One
such a high
second for
speed, then
me.
the
Yeah.
magnitude will different.
Yeah. Yeah. If speed becomes like 99.99999% of speed of light,
Yes,
then 1 second for me might be 10 years, 40 years for
40
Ayush
years or
also.
300 years, might be 300 years also.
Yeah.
It can happen. It can happen.
Yeah.
More the you,
Yeah.
more the
And
with more the speed you are reaching near the sea,
mhm,
then time gets
yeah.
slower for you. Time
Okay.
gets slower for you.
Ayush, can you write that formula for
Okay,
time
sure.
dilation, that so that the audience will uh,
So this is the time,
can get that idea of that time
dynamic time.
dilation, that how much, yeah, how
Or
much speed should we have that to have that time dilation about 1 year, 2 year, or 1,000 year of, or millions of year. Uh, to get that idea, please write down that formula. Okay.
okay, this is the formula.
Mhm.
Can you see or not? Are
Uh,
you able to see?
yes, and yeah, I can see this. And T naught means the time for the person who is inside that train.
Yes.
Yeah.
So this is the formula. Faster you see, if you are traveling, you can put the value like 0.9 c. If you are traveling with 0.9 c speed, then you can
Mhm.
from this value you can say like you can find how much time
Ah,
1 second for you will be equal
Ayush,
to how much time for me.
Ayush,
You can find like that.
Ayush,
Yeah,
Ayush.
yeah.
Please write down that I'm I'm in a spacecraft with near to the speed of light, and you are uh, rest. You are at rest in space, or something
Yeah.
anywhere. You are at rest, and so that T naught is time for me, and T is time for you. so that I audience will get and they will not be confused on that formula.
Subhash, Subhash is clearly Subhash is in spacecraft.
The scrapped and time denote. Okay, yeah, you can show
Subhash
that
is
arrow
in
also.
spacecraft. T sorry. Spacecraft T naught is for this. T naught is time for Subhash.
Okay, and T for Ayush.
I am is Ayush.
T
Ayush.
time is experienced by Ayush in the same event for the same event. Yeah. Okay, and I think now audience are clear about that formula. Okay. Okay. Now I think it's clear. Okay. Explain now. Now explain. Let's explain about that.
Okay, Subhash. Now you continue. Now it's on.
Okay.
I've talked too much.
Okay. You might be tired, so I will
Yeah.
talk about that. Okay. And yeah, and yeah, let's suppose that we are moving with 90% of speed of light. That Subhas is moving with 90% of speed of light in a spacecraft, 0.9 c, and Ayush is at rest. And what will be the time difference between them? Let's calculate that. Please, can you calculate that?
Yeah, T naught divided by if you are traveling with 0.9 c, isn't it?
Okay.
If you are traveling with 0.9 c, then it will be like 0.9 square means 0.81, isn't it? CC will cancel
Yes.
out each other.
Yeah.
Yeah, then you can calculate T naught
Yeah.
divided by 1
Yeah.
0.1.
I'm going to calculate. Okay, don't worry.
Calculate and put the value.
It's about 5.26 seconds.
5 point here
Yeah, 5.26 seconds. It's about.
to 6 T naught.
Yeah, T naught. Yeah, if T naught is 1 second, yeah,
Yes,
or
means
it's like we can.
yeah.
Yeah, we can. Yeah,
Means if 1 second for Subhas will be equal to 5.2 seconds for me. Means if I am on
yeah,
the earth and 5.26 second passed, then it will be equal to 1 second in Subhas club,
yeah,
isn't it? Yes.
yeah.
Now,
Yes, obviously.
if you travel with more speed like 0.9999999 c, then this you can calculate the value and it will be more and more. It will
Yeah,
be like
Ayush,
yeah.
Ayush.
Yeah.
Sorry for calculation. It's about 2.29 seconds.
Okay,
2.29 of T naught.
no, calculation doesn't matter. We are not
Yeah,
in our exam,
going to
so
understand. Okay. Yeah.
the
Yes.
main thing is like it will time will be more, isn't it?
Yeah,
2 point
time will
something second,
start
isn't
to.
it?
Yeah, time will ticks in the slow rate if you move with the uh, faster speed. Okay.
Yes.
Yeah,
After
that's
you
the
move, time
theme of.
slower the time
Yeah,
gets.
yeah. Let's calculate for 0.9999 tenth nine position. What will be the value of for the time difference, so that my audience will get. Oh, there's so much huge time difference between them. If we put more nine between more nine after that 0 point, yeah,
And
they
now
will get it.
put with the value 0.999
Zero point nine
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 nine.
nine 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 C. How
Six.
many nines are there?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, or whatever.
At no, 10. It's about 10. Okay. 10. Uh,
10, okay.
and
1, 2, 3, 4, 5, 6, 7, 8, 9, 10 C. Okay.
okay.
For this value,
Yeah.
you will get uh, if you travel with this value.
Yeah. Oh, that's a very huge number. Ayush. Yeah, T equal to T naught times 22,360.
360, 22,360 means
Yes.
1 second for,
Oh,
sorry, 1 second for Subhas will be equal to 22,360 seconds for me. So
yes.
I think now audience will get the real feel of how time gets dilated,
Yes. And
isn't it?
yeah, Ayush, if
Yeah.
it will be if it will be exactly equal to C, what will happen?
Then in finite, see, you can
Yeah.
see, if here, if in the place of v square, then c square, then 1 minus 1 is 0. T naught by 1 by 0 means it's infinite.
Yeah, infinite. For 1 second for me is
Will be
equal to
infinite time for me.
infinite time per year per Ayush
Yeah.
clock. Yeah, that isn't that elegant? Yeah, that's a very interesting topic of the physics all time.
Yes,
Yeah.
exactly.
I think now audience are feeling about that. Yeah, audience are very clear
Yeah, I'm
about time
sure.
dilation.
I'm
Yeah.
sure about that.
Yeah, and we can also talk about that photon. We know that photon is moving with exactly speed of light
Yes.
in vacuum, and
Means
for that,
infinite time
yeah,
for us
for
will be equal to
equal to
0 second for photon.
0 second, not 0 second, but 0.0001 second. Yeah.
Yeah, nearly zero. We can assume that to be zero.
Yeah, yeah.
Yeah.
And 1 second for that photon is equal to infinite time for
Time
us.
for
And so
yes.
that, yeah, we, we can think something more about that. And let's think about alien. If alien are moving with near with exactly equal to speed of light, if
Mm-hmm.
somehow alien are moving with the speed of light, then for them we are living not 1 second also. We are living
Yeah, yeah, yeah.
nearly. Let's suppose we are living 1 second for alien.
Yes.
Yes,
Yeah,
and
this might
but
happen, man. If they
yeah,
are traveling
but
with quite more nearer to the sea or see, then
yeah,
that might be happen. So
yeah,
for audience, I want to say one more thing. Like it is one method of like time traveling also.
yes, and
This
yeah, we'll talk about that later.
okay,
But
sure.
yeah, yes, and for if alien are moving with very near to speed of light, let's suppose with the speed of light, then the uh, time for 1 second for alien will be equal to infinite time for our time. There will be
Yeah, it
infinite
can
time has
happen, man.
elapsed
They are
between them.
traveling
Yeah.
with much
Yes.
speed, much nearer to the
Yeah.
speed. Then this can be happen.
Yes. And in 1 second, we are doing all those stuffs, reproduction and birth
Yeah,
and death, generation. Everything is going to happen 1 second for that
for
alien.
them.
But for them,
Yes,
also for us, they are living infinite time, and they are
yes.
doing the same thing in that infinite number of time. Isn't that elegant? Isn't that interesting?
Yeah,
Yeah, it's
thinking about this
very
will definitely like fill your heart with the joy, excitement, isn't it? If you think about
yeah,
all these things, then you'll be quite
yeah. This
interesting and
yeah.
energetic like that.
Yeah, this is actually time travel. And if
Yes,
you want to time travel, if you want to go to the future, then just move with the speed of light. Just move in a spacecraft near to the speed of light.
yeah,
Then the age difference when you grew up from that earth,
yeah,
and the age difference of that clock and the clock with you, there will be vast difference in the age. About it might be like thousands of million
yes.
of the years also. Yeah, it depends upon the with
Mm.
what speed with how much nearer to the speed of light you are moving. It
Yes,
depends
it
upon
depends
that.
upon that.
Yes,
Exactly.
this is yeah, this is all about time travel going at future. We used to be like oh, that's is that possible time travel? Okay, hey,
Yeah.
it's very hard. Very hard to time travel because it's very hard to get that speed that we have already calculated that if
Yeah, yeah.
it's about
Even
90%
at zero point
of the
nine
speed of
c,
light.
it's like time difference like 0.56 seconds.
Yes. So uh, it's very hard to get that speed. But why not? There is at least there is theory, and it has been
Yeah,
also proved. Yeah, it has been also proved. And one clock is in Earth surface is placed, and another clock is in a spacecraft moving with the
yeah,
faster speed. And there was like something time was difference. Like
yes,
yeah, it was very quite small because the speed was very less as compared
yeah,
with the
yeah,
speed of
obviously.
light. Like it was like 10 to the power minus 6 second, I think, in the difference between those clocks. But at least there was time
Time
dilation. Yeah,
difference means
uh, yeah,
if we somehow manage to travel with a much more speed, like nearly about the sea, then time difference will be quite more.
yes,
Time different time will get dilated more, and if you come back to the from that journey and return back to the earth, then you will see the future. You will be in the
yeah,
future. You will
yeah,
see your grandsons, like
yes,
you will see your
yeah,
grandson, not grandsons, grandsons of the grandsons also. If you
yeah,
travel with the nearly speed of sea, and after
yeah,
1 year you came back to your home, then you will see your
yeah.
grandsons,
Or like 100 centuries for
grandsons
people
of the
also you can see.
grandsons,
Yeah.
and many centuries might have get past.
Yeah,
That's
this
why.
is the meaning of that going at future or time traveling.
Yes,
This is all about time traveling,
time.
and we talk about time traveling in the future. But after on the another video, we'll talk about going at past also, going at past
That's
also.
it.
Okay, yeah, this was all about time dilation and time dilation from the special theory of relativity.
Yes,
Special theory of
time
relativity
gets dilated.
goes to the time dilation. Yeah.
I'm not too. I have like Subash, you have also know, and mainly there are two ways of time dilation. One is this,
Hmm.
and second you will be talking on our further videos. Like,
Yes,
we'll
and
be talking about that in
if
general
you
theory of
want to
relativity,
time
isn't it?
travel, if you want to time
Mainly there are
travel,
two.
or yeah, yeah.
There
In
might be
last,
other also,
yeah,
which
in
we
last,
don't
I
know.
want to say that
Yeah.
yes,
Con-
in last, I want to say, yeah, in last, I want to say to the audience that if you want to time travel or if you want to go to the future, one thing is reach to the try to reach to the speed of light. Then you can go to the future. Obviously, you can go to the future.
yeah,
And
but
another thing is, another thing is also coming. That is go to the edge of that black hole or a very massive object, edge of that very
yeah,
massive object. Then you
we'll
can go to the
talk
future
about this
also.
in
Yeah,
Subash, we'll talk about this in general theory of relativity. So
yeah.
for now,
This
let's
is
give some
this is
hint to
all.
that to our audience.
Yeah. Okay. Yeah.
We'll
That
talk
was very
about that in more
amazing.
detail in further
Yeah. That
videos.
was a yes. That was very amazing
Yeah,
discussion about physics. One physics discussion that is special theory of relativity. That's very quite interesting, and I wanna suggest to the all the audience that think about more about that, more and more about that. Yeah, and think yourself and ask to yourself that is that right? Is it
yeah,
possible? Yeah, isn't that right? Yeah, yeah, it's right. It's right. But is it possible? Yeah, think yourself. It's a very quite interesting. You can enjoy with that. And yeah, after some time, after like yeah, there is not we are not together. Ayush and me. After some time, if we be together, then we'll make video on the math version of that special theory of relativity also, so that
yeah,
you will feel more and more about that. Yeah, yeah, that's we'll explain more explanation and more that. Uh, more experiment that verifies
yeah.
special
You
theory of
will,
relativity also. And
yeah.
yeah,
From
yeah,
mathematics
we'll
side,
talk
you will
about
be
that. Yeah,
clear on further videos.
yes,
Yeah, from theoretically,
yeah,
you have known everything. I think if you if
hmm,
you think about this a little more, then you will be like you will be
yeah.
excited, and you'll definitely know all these stuffs. If you think a
Yeah,
little
please,
more, I
Ayush,
suggest you to think
please,
on your own also.
yes, Ayush, please, can you stop that? Stop to share that whiteboard?
Yes, sure, sure.
Yes. Okay.
Can you turn on your video? Yeah.
Okay. It was a very quite interesting discussion on physics. Yeah.
Yes.
We also enjoyed a lot
Yeah.
discussing on that topic, and I think audience also
We'll also love that.
enjoyed. Will enjoy with this topic. Yeah. Yes. And there is a very good self and try to think. Isn't that right? Is that possible? Yeah. Like that question, ask to yourself.
Yeah.
And yes. Yeah, that's all about special theory of relativity. And we explained whatever we know. We try to explain
Yeah, we are trying to
whatever
explain
we
that,
know about that.
and
Yeah. Mm-hmm.
we have tried our best to make our audience
And
also know about this and make them feel
yeah,
about this.
it's a very deep.
Yeah.
Yes. Mm-hmm. Yeah, it's a very big or it's a very deep concept on special theory of relativity. Special theory of relativity is very deep concept on physics. Yeah, yeah. We don't know also everything about special theory of relativity, but think yourself. At least we have give some concept of special theory of relativity so that you can think about that. Yeah, yeah, that's all about special theory of relativity. Okay, we'll come with general theory of relativity
On our
on
next
another
video.
video. Yes.
Okay. For
Yes.
now, bye
Okay.
bye.
Okay, bye bye.
Bye
Enjoy this video.
everyone.
Okay, bye bye.
And thank you, Subash, for inviting me on this discussion.
Okay.
We'll,
Okay, it's
I
my
hope
pleasure
we'll
to
make
have
more videos.
yeah. It's my pleasure to have you here, brother. Yeah.
Thank you, thank you.
Okay.
Okay, Subash.
Okay.
Now, bye. It's your
Bye.
time. Take a leave. Bye.